Hello there, everybody. Welcome back from the short break. Moving right along to our last presentation for the day, or night, as the case may be for you. We're going to shift gears back to the technical focus. So this is going to be our final presentation, which will be a technical one, talking about the Xspin blocks and a little bit about how their data collection process went about. And the speaker for this will be Andrea Susani, who's also known as SickPig by some folks. And let me give you a quick introduction of Andrea. Andrea is a software developer for almost 20 years. He's recently transitioned to what they call a full stack software developer, which means he does 4 jobs while being paid for only one. On the right side, this role does give him the opportunity to improve his skills in IT fields such as database administration, system administration, coding, and project management. Holding a bachelor degree in statistics and getting into Bitcoin quite early in 2011, Andrea briefly pool mined with Radeon GPUs, and he hasn't looked back since. So ladies and gentlemen, I'll hand you over to Andrea Susani.
Hey, hello everyone. Do you hear me?
I hear you loud and clear.
Okay, perfect. Hi everybody. It's been a pleasure to be here. As they already said, I'm here to talk about the experiment that produced the fantastic series of posts on Medium by Peter R. Or Peter Reason. So I'm going to tell a story about how the process starts, develops, and ends with all the things that we have learned along the way. So we'll move to the second slide. So what was the goal of this experiment? We need to find a way to measure real-time block propagation in and out of Great Firewall of China, GFC, from now on, using BU nodes, Bitcoin Unlimited nodes. The purpose is to use these measurements to compare the performance of Bitcoin Unlimited propagation time against other measurements for P2P Bitcoin standard propagation time, and also against the fast relay network. Just a quick note, all nodes run on Linux server, deployed using a Debian-based distro, the time between various nodes was synced via NTPD. Okay, they are saying that they are not seeing my video, but for some reason I have it enabled, so I don't know why. So I'm sorry, but the video is not available. There's a technical inconvenience. I'm going on with the presentation, then I'm sorry about it. Next slide. And what was the original plan? So we divided the test in 2 phases. The first one was about measuring the propagation time of blocks from outside GFC to inside the mainland China, and so going through the GFC. The second test phase of the test was aimed to measure the propagation time the other way around, from mainland China to the rest of the world, going through GFC. So we have both of them were divided in two days they doesn't mean 24 hours, but 2 steps. The first one with Xthing feature disabled, and the second one with Xthing enabled, just to have a baseline to compare of for both of the two steps. So the NAC2 topology was quite simple in the beginning. There were two nodes inside main China nodes, let's say, one in Shanghai and one in Shenzhen. Then there's a node on the border of the Great Firewall of China in Hong Kong, and then there were other 2 nodes in the west side of the world, in London and in Washington. We use strange acronyms because it's USW, doesn't stand for United States West, but Washington. So for the one that we'll start seeing the presentation later, I just want to be clear that this is Washington rather than the west side of the United States. So what we learned is that actually sticking to this kind of topology was quite hard, because nodes BitcoinD are not developed to be easy to administrate in this kind of scenario. They are more thinking and more developed for belonging to a broad P2P networks. In fact, BitcoinD span out 8 outgoing connections independently from the fact that you don't want to, and there's no way to stop it by the means of configuration parameters. So you have to all change the code as we did, or use a firewall just to limit the connection incoming and outgoing and outgoing. So we apply both of these 2 approach. Later on, we switched to just the second one, so patching BitcoinD to the couple max incoming connection parameters and adding a new one to limit the max outgoing connection. It was an easy change, but at least it was something that permits us to really stick to the topology that I described before. So next slide. So what we learned about BitcoinD and Bitcoin Limited in this case after starting to develop and deploy the first part of the test. So 3 main points actually. Mempools need to warm up to reach a decent level of synchronization. So in the first 8 to 24 hours, the mempools of the nodes are quite out of sync, and so that means that Xthing is less efficient, because the more transactions the 2 nodes share, the more efficient is the process of Xthing block. Another thing that we learned and we didn't expect was that there were quite a few big outliers, not really big in terms of frequency, but in terms of time. A few blocks takes a very long time to propagate, and this is something that I totally unexpected to me. Anyway, we will see later how we have dealt with it. Another thing that we started to think at that time is that maybe Hong Kong nodes wasn't able to keep the pace inside both Shenzhen and Shanghai. So other thing that we have learned is that apart from the fact the mempool needs to warm up, mempool maybe, or we didn't prove in a deterministic way, but in our opinion, tend to go out of sync after after having warmed up. In case of low numbers of peers, and this is precisely our case because we have only five nodes in our controlled test experiment, and this is exactly the case when we start seeing the mempool going out of sync. We have tried to increase the mempools, and it gave a better compression in terms of bandwidth, but also bigger Bloom filters. Other than that, even in the case of bigger mempools, outliers were still there, and at that time, Peter Schipper changed the code in a way to give a higher priority to extend network messages with the aim of mitigating this outlier effect. We will see how it worked, or if it worked, in the next few minutes. So, just a little clarification about outliers. It was not something peculiar. It's not something specific to Bitcoin Unlimited. It was something that happened, and not something that is specific of our test design. Because since we have found those outlier, we have started thinking about possible causes, and we have started to think about tools to evaluate our hypothesis. So what we can say after this initial test is that the lower the numbers of peers, the greater are the number of outliers, and also the size of the outliers in terms of seconds tends to be higher. So we have tested it also in a different context, and they do happen even without the Great Firewall of China in between, and they happen also with plain core 0.12. So it's not something specific of Bitcoin Unlimited. It's something that was already there, and this is something that I can say that it's something that we didn't explain in any detailed way. We are still searching for the cause of the main cause of causes of this phenomenon. So move on. So as I told before, we thought that Hong Kong wasn't powerful enough to keep up the pace. So what we have done, we have had another node along the border in Tokyo, because some folks told us that the connection, usually the connection between mainland China and Japan is not as bad as for other Western nodes. So we have had a new node in Japan, and we have changed the topology accordingly in such a way that Tokyo will serve nodes to Shanghai, and Hong Kong will serve node to Shenzhen. And we will see how it will have improved the situation in the next slide. So the situation somewhat improved. There were still some big outliers while crossing the Great Firewall of China. Still, having another node on GFC border facilitated the crossing, and I might say that the change at code level made by Peter about the prioritization of the extend net message helped a lot. And a thing that I thought during the test is, but why not make that change that would somewhat put Tokyo and Hong Kong on the same level, in the sense that both of them serves block to Shanghai and Shenzhen without only one link between Tokyo and Shenzhen, but two links between the new node and Shenzhen and Shenzhen, and two links between Hong Kong and the other mainland nodes, mainland China nodes. it was a way to somewhat set up a failover mechanism in a way that if one of our border nodes fail somewhat, the other could help and serve the block instead. And it helped, like we are going to see in the next slide. So, other thing that we, as the conclusion of the first step of the test, we have tested the same thing, but going back to small mempools, and we have observed that the difference was not as big as we thought, and having smaller mempools gave less pressures in terms of resources on nodes, so less bandwidth, less CPU for validate transaction, and so on. And another thing that I thought, and I did during the test, is one of my hypotheses was that maybe the outliers was caused by some network glitches between various nodes. So I've installed on all the nodes network latency monitor tools in a way to determine if these outliers happened while there were a network glitch or of some sort. Unfortunately, this wasn't the case. So the outliers wasn't really due to network problems, but maybe in the code, maybe something in the code or something in our settings. In any case, these settings helped us to exclude one possible reason for the outliers. Another thing is that JP in Tokyo node has been highly beneficial. In fact, JP to Shanghai propagation time is an average of 0.75 seconds, so 750 milliseconds. And of course, the combination of modification made by Peter, the queue jumping for network messages, extend network messages, plus the fact that we have introduced a new node, improved the situation a lot. That said, as a final result, initial result for the second step, the second phase of the test, so going from mainland China through the Great Firewall of China and to Western nodes, this is the second step, and I can say that we have in this particular phase we stopped to use IP tables or firewall to enforce our network topology. We have just used the patch that we developed to control this kind of connection, inbound and outbound, in such a way to simplify the setup. And things started to pan out. In fact, this is the data that we see is quite good. In fact, from Shenzhen to Tokyo, the average time of propagation was 0.97 seconds. From Shanghai to Japan was 0.91. From Shenzhen to Hong Kong was 0.71. From Shanghai to Hong Kong was 1 second, 0.31. So these are well, actually good, pretty good, if I have to say. Still, every once in a while, it seems that blocks get stuck, and stuck in the sense that it took a lot to propagate, as the famous outlier was still there. So, during this second phase of the test, we apply further enhancements to our setup and to our codes. Peter Schipper applied two fixes for unnecessary downloads of headers when a new peer connect. This is a problem that we inherited from Bitcoin Core, because Bitcoin Unlimited is a fork of Bitcoin Core 0.12, I think. I suppose, I don't remember, but I think it is high probability it was 0.12. So then Peter, during this phase of the test, applied and developed further enhancement to the priority queuing to the Xthing network message. And another thing that could have helped, we are not sure, is that during those days, also at present because they are still there, we saw that in the log that we have a high number of incoming connections, just the initial thing where the peer just say, hey, I'm here, this is my version. And in that case, those were almost a dozen per second, and the source of this connection was unknown IP group, a class B IP group, if 52.51, and we just decided to mitigate the fact this useless connection, maybe a DOS, we don't know, but we have tried to mitigate by block this kind of connection by the means of Bitcoin set command, and also by iptables rule to just block this kind of useless connection, just to avoid to waste resources in this case. And then Peter even apply and develop connection slot attack mitigation inside the software. This is something that could have helped. We don't know for sure, but for sure, the sure thing is that our nodes with this kind of change applied just use less resources to be part of the network. So, concluding this first part of the talk, I want to say how long it take to do all this data gathering and all this setup. So in the beginning, we see that we thought to do it in 4 days, but unfortunately, we have to iterate the first 2 days 10 times each, and the third and the fourth at least a dozen combined, so 6 per day. So we spent a lot of time understanding the P2P Bitcoin nodes and understanding our Bitcoin Unlimited client in relation to this P2P network, and we changed and fine-tuning a lot of things. We developed soft announcement. We test different hypotheses, and sometimes we have to fix pilot errors, minor errors, while conducting the test. So let's move on. And at the end, we thought, since we have observed that we Bitcoin D, not only BU, but Bitcoin D in general behaves better with a higher number of peers, why not just change the test in a way to use these characteristics? And this was an idea of Peter Rizun, and we all agree that it was a good idea, and we set up a test that I call the bin, because there are 4 bin. Bin 1, where blocks that belong to bin 1 were regular blocks over normal, propagated over normal P2P network. Bin 2 was Xthing block propagated over normal P2P network. Then bin 3, it's the same, and bin 4 the same of the mirror of bin 1 and bin 2, but the blocks went through the grid firewall of China. So let's move on. This is the topology. So we have our 6 nodes connect to each other, and all the nodes have no restriction, no constraints, and could be connected to all the rest of the P2P network, be the nodes in mainland China or in US, Europe, whatever. But one thing that we make sure was to have a good block source from inside mainland China. In this case, Antpool provide us with a block day Bitcoin nodes that provide blocks to our Shanghai and Shenzhen node. So let's move on. So we decided to to reach to gather a lot of data, because we thought that it was necessary for having a good base for the results that we want to share. So the fact is that to fill the bin where in this case was I don't even remember, but was bin 1 and bin 3, we have to somewhat force our network to accept regular blocks, because as a rule, once a node has Xthing enabled, it preferred Xthing blocks over regular blocks, because there is a preferred timer of 10 seconds time, that every time that a new block is announced, the Xthing nodes wait for 10 seconds to get a Xthing block from one of his peers. If after 10 seconds it didn't receive any blocks from BU node or Xthing enabled node, it starts searching for and accepting regular block. So we have to repeat the test multiple times, 4 iterations in this case, to get enough blocks in each bins. The last 2 iterations run with Xthing disabled to fill bin 1 and bin 3. So more or less, one iteration lasts for 2 days or a little bit less on average. So at the end, we had impressive results, as you might know. Other presenters on this conference already show this, but just let me quickly go through this kind of results. So 60 transactions per second, in case we want to leverage the propagation time that we could have with the Xthing. So this is something that really stuck to my mind, because it's very a message, a very heavy message, a very important message that we have shared and with the community. And I didn't want to go over the other, but this is something that really impressed me when I realized that if Xthing will be enabled on the entire P2P network, we could have 20 times more that capacity. And in terms of transaction, really the thing really emerge and keep your attention. Anyway, so let's move on, and we are going to present the further improvement that we have, we as community, and particularly in this case in Peter Chipper, we have think during this phase of the test. So the main thing is that Peter, inspired by Hfinger, introduced a new concept, a targeted Bloom filter. So the targeted Bloom filter, instead of including only and considering only transactions belonging to the main mempool, it starts looking at also the orphan pool. It's another pool, a less famous pool, but it's there, that contains all orphan transactions. So it could be that this kind of transaction could be included in the next block, so could somewhat improve the efficiency of Xthing. And in fact, it was the case. And one of the main effects is this technology, this improvement, let us decouple the Bloom filter size from the mempool size. As we see, well, as we discovered in the beginning, the higher the mempool size, the higher were the Bloom filter. So yes, with a bigger mempool, you could get a higher compression in terms of transaction, but you get also a bigger Bloom filter. With this new thing, Bloom filter isn't linearly linked to the mempool size. So it is a good thing, and more enhancement and more tuning to this technique is on the pipe. So expect new thing from the BU group. Another funny thing: 2 days ago, or maybe 3, I don't remember. Just look at issue 8243. Even Bitcoin Core discovered that including orphan transaction that belongs to orphan pool could improve the performance of compact block, as we already see during these days. Before my presentation, Chrono Cryptos just talk briefly about compact block. That was the technique that is developed by core developer and is the twin of Xthing technology. So even they discovered the thing. So it's a good thing to having discovered before. In any case, what we have learned during this long journey, it lasts almost 2 months, all this process. How Great Firewall China bites hard. Even SSH latency when you are typing is a nightmare. So Mosh server, I don't know if you know about it. It's a particular way of exchange, of connecting remotely. It's based on SSH, but use UDP and other things to improve the latency, and it's a good thing for mobile networks or network where the latency is very high. Could help, but still, GFC is very a beast, let's say. Another thing, compile in one place and deploy everywhere. And while it is strip your binaries, that means move away from the binaries all the symbols that could be used during debugging, but are very heavy in terms of size. In fact, Beacon D from once stripped is something like 5 megabytes, whether the original before the stripping is 60, 70, I don't even remember. So when you had to copy this kind of file through the GFC, it could be irritating. So having to copy 70 megabytes instead of 5 could be really really annoying. In fact, sometimes you could get very low performance in terms of transfer. So you could get also 20, 40 kilobytes per second. It took a very long time to distribute your binaries. Setting up a latency monitor, it helps to discriminate network glitches from real Bitcoin issues. Another thing, one of the most important, if I may say, the more peers is involved in your setup, the better the propagation times. So let's move on. Outliers are still there, even if they are less pronounced. All the announcements that we have applied and developed helped significantly, but they are still there, and they're still there. Also, if there is no Great Firewall China involved, also for Bitcoin Core 0.12, there are some problems somewhere in the code, in my opinion, and we have to hunt it down. And the good news is that the Zerg, Andrew, is hunting them down, and is developing in the context of his latest development, is trying to understand what's the problem and how to mitigate it. And another thing that I want to mention, even if I don't want to describe it, is X validation, because it's something that is not always known, but Xthing is a combination between the thing that everybody knows and everybody have seen in this presentation in the day before, but another thing that is pretty cool is that Xthing lets you propagate one transaction, or a transaction only once rather than twice, as it is in Bitcoin Core or any other implementation before Xthing. The other thing that is less known is that Xthing and BU lets you validate transaction only once instead of twice, because once the transaction is validated, once our transactions are included in the mempool, the transaction will be validated. Core and other implementation, MBU, before the Xthing has been deployed, validate transaction twice. Once when the transaction will be included in the mempool, and once when the transaction will be included in the block. Now the second one is skipped in the case of BU, Bitcoin Unlimited, and this is, in the way that we call it, is X validation. So we cut it also the validation time and it's quite good because also you could cut the CPU time to validate the block. Well, of course, Xthing is great, but it just and I think that we already know and we already discover. And last thing that I want to say is that Peter Schipa is working on further reducing Bloom filter size, and this effort is called Targeted Bloom Filter 2. So another thing that I want to say is that if anybody is interested in the data that we have gathered to validate our results, to study, to develop other results, to analyze them, they are available. We are very fond to share this data to anyone that wants to validate our result or find new thing in our data. So another thing, well, we have ended my presentation. I'm thankful for the attention, and of course, I'm here to respond to any questions that you want to ask me.
Hi, Andrea. It's Jerry. Yeah, I just wanted to just quickly step in and say, yeah, this is I really like the fact that your presentation was very technical and outlined like the fact that, you know, this data and real analysis behind these solutions. It's at least to me, this is very, very interesting, because having heard from many people that a lot of people talk too much about what we should do, but nobody actually does it. This is really, really good just to see, you know, this actually being done. And it sounds like you guys took, not just you, but everybody who was involved in this took about 2 months to put this all together. And this is exactly the kind of thing that everybody has been calling for, including core devs and including everybody. And it's just really good to see the actual method. And I look forward to hopefully that people watching this video and getting interested will try to reproduce it, because that's part of proper scientific method. You know, academic review, it requires people to take the same method, or maybe different method, but try to reproduce the results in order to confirm the conclusion. So I have to applaud that. You know, if this was a live conference, I would have asked for applause. I'll just give you this. I'll just give you this little sign, this little emoticon. That's the applause out there for. Thank you for doing this analysis. Thank you for collecting the data, and great work.
Thank you. One thing that I really appreciate about Bitcoin Unlimited group of, or I don't know how to call it, the people that are developing this client alternative implementation is the way that we approach reality. Let's say we are very fond of test what we are doing in the real P2P network, the real thing, and it's a need more than anything else. Are we doing things properly? Are the idea that we have a reality match the actual reality? So having this kind of attitude is one of the things that makes me engaged in this process and makes me really appreciate the fact that I spent a lot of nights doing this kind of thing. But at the end, I have to say that it was a pleasure, and I am very, very thankful to everybody involved, because it was a very good thing in any aspects. So, okay, are we going to wait for question another few minutes? I don't know how to develop in this. Okay, one answer. You could answer, do you think the Bloom filter is needed? Yes, I do think that the Bloom filter is needed, and I have I have heard and read a lot about critics or other kind of angles, let's say, that state that Bloom filters are not needed, that maybe there are wasteful space that we have to, in any case, propagate through the network. I have to say that, like I've just said, I like to base my statement and my reasoning on facts, and we have proved that Bloom filters are quite efficient. I know that there are other implementations that have the same aim of Xthing, like CompactBlock from that course, that even in the mode, the low bandwidth mode, that are the one that share the same goal of Xthing, are not going to use Xthing. I will very curious to read through a paper or a series of blog posts where they are going to show us that they're right. But I really do like this kind of results based on real tests, like we did. So, in my opinion, Bloom filters are needed, because mempools could be very dishomogeneous. It depends on the part of the network where your nodes are. One thing that I think is that the P2P Bitcoin network are quite big, but especially we don't know how it behaves really, because it's a very complex system, and we don't know how the information flows for real. We know the rules, but the reality is another thing. So I don't know. It could be that they will find a magic thing, a magic trick that sync all the mempools of the P2P network. So in that case, maybe, I don't know, Bloom filter would not be needed anymore. But I want to see data before saying that this is true. I have an open mind. It could change my idea, but I can see that I need real data. This is what I have to say about it.
Andrea, I have a question myself, actually.
Yeah.
I'm speaking as opposed to typing it because for some reason panelists can't type into the QA box. But as part of your test, you had Antpool helping you guys out by giving you a node which would feeding you blocks through the GFC. So I'm curious to know your interactions with Antpool.
Okay.
They obviously were interested enough to help you guys develop this idea and get real scientific data. So what was have you shared these results with them? What is their reaction? Are they interested about the results?
I have not had contact, direct contact with Antpool representative, but I know that Andrew, not Andrew Stone, but Andrew Clifford, had deal with this communication, and I'm sure because I made the same question to Andrew Clifford because I was curious. And he said that they were very interested in our in our tests because I think that they were fond of having something real to look at, a proper test with a lot of data, with results that came from the interaction between the nodes and the real P2P Bitcoin network. So from indirect experience, I have to say that they look very responsive. Every time that I have a request, a technical request that go through Andrew, proxied by Andrew, they have a very low latency in responding to me. So that means that they were there and they were looking at the result, and they were fun. They want to help. So from my experience, that was not direct, but I can say that they seems very they had an empathetic attitude versus our experiment. This is what I can say, but you could ask Andrew Clifford for this kind of answer, this kind of question. But this is what I have now.
Sure. Thank you.
You're welcome.
Does anybody else have any other questions? We're coming around to the hour anyway, so yes, I guess with no more questions, thank you very much, Andrea.
Thank you.
Thanks for sharing that with us. I hope if anybody wants to get in touch with Andrea or anybody else in the Bitcoin Unlimited team, I guess the contact information is on the screen.
Yeah.
And I've as part of information sharing, I encourage everybody who's interested to reach out to somebody and get involved and learn about it.